These are the 1.3b notes for PreCalc. This is all about parallel and perpendicular lines. So what are parallel lines? We're going to talk about those first. Parallel lines, you guys know, are two lines that never cross. If they never cross, it means they have to have the same slope. So that's as easy as saying if the slope of one of the lines is 1/3, the other slope automatically has to be 1/3. So let's look at example number 1. Show that L1 and L2 are parallel. L stands for lines. And I need to show that they're parallel. To show that they are parallel, I need to compare their slopes. So our first line, L1, actually already is in slope-intercept form. So my slope, all I have to do is look and see that it's -2/3. L2, however, is not in slope-intercept form, so I'm going to solve for y. I subtract 4x. 6y equals -4x minus 18. And I divide by 6. Now for the fraction -4/6, I'm going to go ahead and reduce that by 2. And that leaves me with -2/3 x minus 3. So now that it's in slope-intercept form, I can simply look and I can say, okay, I know my slope is -2/3. Because the slopes are the same, we have shown that the lines are parallel. So all it's asking you to do is show. So all we have to do is find the two slopes, make sure they're the same, and we're done. For example number 2, find an equation that is parallel to the line 2x plus y equals 6 and passes through the point 2, -3. So again, anytime we're dealing with parallel or perpendicular, we do need to make sure that we are finding the slope. So I'm going to take this equation, the 2x plus y equals 6, and I'm going to put it into slope-intercept form. Subtract 2x. Y equals -2x plus 6. So I know my slope is -2. In order for something to be parallel, I would just have to make sure that I use the same slope. So when I do the next part, I'm going to plug this in as x1 and y1, and I'm going to use this for my m. We're going to plug it in a point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. So y minus -3 equals my slope, x minus x1, which is 2. Take a moment, work through the rest of that problem, see if you can get that into slope-intercept form. All right, we should end up with a final answer of y equals -2x plus 1. And we are done. The directions were asking us to find an equation. We did. And if you remember, your first slope was -2, and this slope right here is -2, which means that they are parallel. Let's move on to perpendicular lines. So for perpendicular lines, they have to cross at a 90-degree angle. So this angle right here in the corner on each of those has to be 90 degrees. So the thing about perpendicular lines, in order for these to cross at 90 degrees, they have to be the opposite reciprocal slopes. The slopes have to be opposite reciprocals. So by opposite, I mean positive versus negative. And reciprocal, remember, is when we flip the fraction. Okay, let's take a look at example number 3. Find the perpendicular slope of each slope given. So we're not given the entire equation, just the slope. So for part A, I have to do 2 things. I have to make it the opposite sign, and I have to flip the fraction. So for part A, you would end up with negative 2/3. As you work through B, C, and D, keep in mind that for negative 8, you can always put it over 1. Same thing with 0. Try those, and then we'll go through it. All right, so part B, you should have gotten 5/1, which would just be written as 5. Part C, oops, this should be a positive. Positive 1/8. There we go. Positive 1/8. And then for part D, so when you write this as 1 divided by 0, if you remember, we are not allowed to divide by 0 in math. So anytime that happens for a slope, you get an answer of undefined. Remember, a slope of 0 looks like this. So an undefined slope would be your vertical line, and that would have a slope of undefined. For example number 4, write an equation that is perpendicular to this equation and passes through the point 1, -2. So anytime you're dealing with parallel and perpendicular, you have to work with the slope. So I'm going to start with this equation, and I'm going to solve for y. Put a little 1 in front of this x here. See if you can solve for y for that equation. So we should have got a final answer here. Sorry, not a final answer, a partial answer. Like that. Your slope is -1/3. We don't want the slope to be the same. Remember, we have to change the slope over, make it perpendicular. We would write it as positive 3/1, which would just give you 3. When we do our equation, we have to make sure that we are using the 3 as our slope, as well as the 1, -2, as our x1 and y1. So x1, y1, and our m. Plug this into point slope form. Y minus -2. Use your perpendicular slope that we changed from -1/3 to 3. X minus 1. So for parallel slopes, you use the same exact slope. But for perpendicular, please make sure you change it over. And from here, same old, just go ahead and distribute. Subtract out your 2. (3x minus 5). All right, let's look at the back side. How do I graph parallel and perpendicular lines? So I've got a couple steps here to do. So the first thing, it says graph the line y equals 2/5 x minus 8. And then label it with L1. going to go down 8, put a dot, up 2 and over 5, up 2 and over 5, all right, we'll call that L1. The second part says to graph the line that is parallel to L1. So we know it has to have the same slope. And it has to pass through the point 3, 4. Now, you could do something similar to what we did on the front side. You could plug things into the equation, but there's an easier way if you have a graph. If I plot the point 3, 4, right here, I can simply make the slope from that point. So you're going to go up 2 and over 5. Down 2, backwards 5. Just connect it like that. And we'll call that L2. So we didn't have to use the equation on that one. We just simply used the slope as well as that point. We just started at that point. Okay, so the next part, graph the line that is perpendicular. Perpendicular, we have to do the opposite reciprocal slope. So we were working with 2/5, but we're going to change it over. Think about what the opposite reciprocal of 2/5 would be. -5/2. All right, so we're going to plot our point 1, 1. And then I'm going to go down 5 and over 2. I'll label that L3. All right, now the question asks, what is the relationship between L2 and L3? So L2 is the blue line, L3 is the pink line. So what do we think those are? Those are going to be perpendicular. One has a slope of 2/5, so L2 has a slope of 2/5, and L3 has a slope of -5/2, and those are opposite reciprocals. Okay, so for the last example, what about lines that aren't parallel or perpendicular? The two tables shows linear functions. Decide if the lines are parallel, perpendicular, or neither, and justify your answer. So for our slope is just comparing the y's and the x's. So the slope formula is y2 minus y1 over x2 minus x1, but pretty much it can be written as the change in y over the change in x. That's what y2 minus y1 is. So let's look at the change in the y's and the change in the x's on each of these tables. So when we go from 3 to -2, this is kind of similar to what we do in the flow chart. That change is -5. From -2 to -7, the change is also -5. All right, for the y's, from 3 to -1, let me change colors here. From 3 to -1 is subtract 4. And from -1 to -5 is subtract 4. So it's the change in the y's, -4, divided by the change in the x's, -5. And we can write that as 4/5. So that's one slope. That's the slope of the first table. See if you guys can do the same thing on the second table and find the slope. All right, so make sure your change in y's goes at the top. Your change in x's goes at the bottom. And that gives you 3. So then I compare 4/5 compared to 3. Are they parallel? Are they exactly the same number? Obviously not. 4/5 and 3 are not the same number, so they are not parallel. Are they perpendicular? Are they the opposite signs and the reciprocal of each other? No, they're actually neither of those. So this just falls into a category called neither. It means that your lines are crossing, but they are not crossing at exactly 90 degrees. Maybe something like this. They cross, but they're not at 90 degrees. All right, great job today. If you have any questions, you let me know.